All right, so last class we finished example 2, part A from section 2.4, where we're talking about polynomial and polynomial-like equations in one variable. And we covered this fact that for higher degree polynomials, the GCF factoring method and factoring by grouping can be very effective. So in part A, we factored by grouping. We found our solutions. Solutions were negative 1/2 and plus or minus I. So now let's look at another example. So here in part B, we have y cubed plus 8 equals 0. Well, notice that 8 is the same thing as 2 cubed. So this is really y cubed plus 2 cubed. And we're adding this, so we can call this a sum of cubes. Say sum of cubes. And the formula for factoring a sum of cubes, so the formula for factoring a cubed plus b cubed is equal to a plus b times the quantity a squared minus a times b plus b squared. Okay, so for us, our a is going to be y, and for us, our b is going to be 2. So now what we're going to do is we're going to factor y cubed plus 8 using this expansion here. Okay, so now we are using this factorization using the fact that a is y, b is 2. So doing that, we get this equation y cubed plus 8 is factored as y plus 2 times the quantity y squared minus 2 times y plus 2 squared, which is 4, and that's equal to 0. So we can now have that y plus 2 is equal to 0, or y squared minus 2y plus 4 is equal to 0. This gives us y equals negative 2, so that's one of our solutions. And then here we can use the quadratic formula. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And for us, the coefficient of y squared here is an understood 1. So we know that a is equal to 1, b is equal to negative 2, and c is equal to 4. So we get that y, using the quadratic formula, is negative times negative 2 plus or minus the square root of b squared, which is negative 2 quantity squared, minus 4 times 1, which is our a, times 4, which is our c, all over 2 times a, which is 1. So now simplifying, we get 2 plus or minus the square root of 4 minus 16 over 2. That is equal to 2 plus or minus the square root of negative 12 all over 2. That's equal to 2 plus or minus the square root of negative 4 times 3 all over 2. And simplifying further, remember whenever you have a negative underneath the square root, that means an I comes out. The square root of 4 is 2. So we get this is 2 plus or minus 2i, the square root of 3, all over 2. And we notice that each of these terms here have a 2 in common. So this simplifies to 2 over 2 plus or minus 2I square root of 3 over 2. Those 2's cancel, leaving us with 1 plus or minus I square root of 3. And so our solutions for this problem are, or is, the set consisting of -2 and 1 plus or minus I square root of 3. That's part B. Now, part C. Here, we have 5z cubed plus 28z squared equals 49z. So, we are going to start this one by subtracting 49z from both sides to get this equation equals 0. Now, looking at each term here, we have a z in common. So we're going to factor out a z, and we're left with 5z squared plus 28z minus 49 equals 0. And now we say z equals 0. Remember, because we have a product, so z times this is equal to 0. So that means z equals 0, or that means 5z squared plus 28z minus 49 is equal to 0. Z equals 0, that's one of our solutions. Here we can factor it or use the quadratic formula. We're going to factor it here. So 5z factors as 5z and z, and we need to think of two numbers that multiply to be -49. That would either be -7, that would be -7 and 7, or 49 -1. And we have to think of a combination that allows our middle term to add up to be 28. So that would give us 5z minus 7 and z plus 7 equals 0. So just if you want to pause and check, you can pause and check. Remember, use the FOIL method. 5z times 7 is 35z, and then -7 times z is -7z. 35 minus 7 is 28. So that's how we know what we wrote is correct. Okay, so using our 0 property, we get 5z minus 7 is equal to 0, or you have z plus 7 is equal to 0. This means 5z equals 7 because we add 7 to both sides. Now we divide both sides by 5 to get z is 7/5. Here we subtract 7 from both sides to get z equals -7, which means our solution set consists of -7, 0, and 7/5. That's our solution. The best way to learn how to factor or solve polynomial and polynomial-like equations is to go through examples. So we're going to go through 2 more examples, and that's going to be the end of this section. Okay, so now we're going to solve the following equations by factoring. This one looks a little different. We have 3x to the 11/3 plus 2x to the 8/3 minus 5x to the 5/3 equals 0. So we look here at each exponent. They all have a denominator of 3. That's great. So now we're going to look to see what's the smallest one, and we're going to factor that out. Well, 5/3 is. So we're going to factor out an x to the 5/3. And whenever we do, that's going to leave us with 3x to the 6/3, right? Because 5, whenever you multiply x to the 5/3 times x to the 6/3, that means you add the exponents. So that would be 5 plus 6 over 3. That will give us 11/3, okay? So we continue, plus 2x. And now this exponent, remember we want it to be, add up to be 8/3. We took out 5/3, so that leaves 3/3. Minus 5, because we factored out the x to the 5/3. That quantity times x to the 5/3 is equal to 0. Simplifying, we have x to the 5/3 times 3x to the 6/3 is 2. So that's squared, plus 2x, 3/3 is 1. So you can choose to write a 1 here or just don't write anything. It will be an understood 1. Minus 5 equals 0. Okay, now using our 0 property, we have x to the 5/3 equals 0, or we have 3x squared plus 2x minus 5 equals 0. Here, we want our exponent on x to be 1 because we're solving. So that means if we have x to the 5/3, we need to raise that to the 3/5 so we can have a power of 1 here equals 0 to the 3/5, but that's just 0. So we have x is equal to 0. And over here, we can factor. Remember, again, you want two numbers that multiply to be -5, but factoring in how you can factor to 3x squared, we want the sum of the outer and or the last and inner terms to give us the 2x. So you have 3x and x because that's 3x squared. And then we can multiply 5 times -1 or -5 times 1 to get -5. So we're going to put a plus 5 here and a minus 1 there because that gives us -5. But we remember you have to check to make sure your middle term adds to be 2x. So checking our last, we get -3x. Our inner, we get 5x. 5x minus 3x is 2x. Perfect. So we have this product equals 0, which means 3x plus 5 equals 0, or x minus 1 equals 0. Solving for x here, subtracting 5 from both sides, we get 3x equals -5, or x equals -5/3 because we have to divide both sides by 3. Solving this one, we add 1 to both sides to get x equals 1, which means our solution set consists of the three values -5/3, 0, and 1. That's example 3, part A. Now part B. Part B, we have x to the -2nd plus 8x to the -1st plus 15 equals 0. Now this one is different because we have negative exponents involved. So we're going to use our substitution method that we learned earlier in this section on pages 1 and 2. So now what we're going to do is we're going to let A be equal to x to the -1. One thing to note here, just note, just because we want to figure out our approach, x to the -2nd is the same thing as x to the -1 squared, right? Because if you have x to the -1 times x to the -1, that's equal to x to the -1 plus -1, which gives us x to the -2nd, okay? So that's helpful because we know we can rewrite this x to the -2nd as x to the -1 squared plus 8x to the -1 plus 15 equals 0. Now, using the fact that we're saying a is going to be x to the -1, we can then rewrite this equation as a squared plus 8a plus 15 equals 0. Now it has a quadratic-like form. So now we factor a plus A squared factors as A times A. 15 factors as 15 and 1, or either 3 and 5, 3 times 5. But we want our middle term to be 8, so that's how we know we use the 3 and the 5. And you can pause it and check it. But this is how we factor it. Using the 0 property, this means A plus 5 is equal to 0. Or we have A plus 3 equals 0. This means we have A equals negative 5. Or we have A equals negative 3. But our goal is to solve for X. So let's do that. So we substitute X to the negative 1 back in for A. So we have X to the negative 1 equals 5. Or remember, if X to the negative 1 equals 5, then that means X has to be the reciprocal of 5. X to the negative 1 equals negative 5, not positive. It should be a negative 5. So remember, if X to the negative 1 equals negative 5, that means X is the reciprocal of this. So X would be equal to negative 1/5. Here we have X to the negative 1 equals negative 3, which means X is the reciprocal of negative 3, which means it's negative 1/3. So we get our solution set is the set consisting of negative 1/3 and negative 1/5. And that's it. So this concludes our section on polynomial and polynomial-like equations in one variable. We learned how to solve quadratic-like equations, solve general polynomial equations by factoring, and solve polynomial-like equations by factoring. Happy studies!